Hi guys, welcome back to my channel Maths Made Easy with AB. So this is the fifth lecture. This is the fifth lecture of Play with Graphs. So basically till now we have studied about various straight lines, how to draw straight line, parabola, ellipse, hyperbola, circle, the basics of those. And also we have seen how to draw trigonometric function, exponential, logarithmic function. So in this lecture what we will do is we will cover some special functions. The special functions we mean modulus function or the absolute value function, the signum function, the greatest integer function, the fractional part function and the least function. Yeah. So these are some of the functions that we will be least integer function. These are some of the functions that we will be covering in this lecture. So very shortly and very simple language, I'll make you understand what are these. So directly I'll start first with the absolute value function or the modulus functions. So guys, before I start with modulus function, I will be very brief here because I have already made a series of 6 videos wherein you can understand in and out about modulus function. So you will get the graph of modulus function there also. So I'll simply define y is equal to mod x is equal to x is equal to x if x is greater than 0, is minus x if x is less than 0. So this is greater than equal to 0. Yeah. So if x is greater than equal to 0, y is equal to x graph you have to draw. If x is negative, that is less than 0, y is equal to minus x graph you have to draw. How to draw y is equal to x and how to draw y is equal to minus x has already been covered in which chapter? Drawing a straight line, play with graph part 1. So this is the graph y is if x is, so this is x axis, this is y axis, right? This is x axis, this is y axis. If x is, so this is 0, 0, this part x is positive, this part x is negative. If x is negative, y is equal to minus x. If x is positive or 0, this is the graph. So this is the graph of y is equal to mod x. So mod x, this function is also known as the absolute value function. So I'll write it over here, absolute value function. So if somebody is saying absolute value function, quickly understand y is equal to mod x is what is being referred to. Yeah. So it is the numerical value of x. So next let us quickly get into the signum function. The signum function, very important for JEE examination. Also in schools these days in class 11th and 12th you frequently get these questions. So the next is signum, S-I-G-N-U-M. S-I-G-N-U-M, signum function. Yeah, so this is function that I have written. So signum function is denoted as SGN. Y is equal to SGNX. So this is signum function. Yeah. So how is this defined? Is equal to mod x by x. Signum function y is equal to signum function is equal to mod x by x if x is not equal to 0. If x is not equal to 0 and this is equal to 0 if x equals 0, I am not writing if over here. If x is equal to 0, then this value will be 0. So sometimes many of you might write mod x by x, or you can also write x by mod x. So any you can write, the function remains the same. So y is equal to signum function is defined as mod x by x when x is not, or x by mod x when x is not equal to 0, and 0 when x is equal to 0. So now understand one thing over here. See this part. Y is equal to what I have written, mod x by x, guys. Understand? So if x is not equal to 0, if x is 0, guys, the value is 0. If it wouldn't have, I wouldn't have defined it as 0, then it would have become 0 by 0 in defined form. But signum function is there and the value has been defined. So at 0, x is equal to 0, the value of y is equal to 0 given. So this is the signum function, definition of signum function. Yeah, not an indeterminate form. So now guys understand, when x is not equal to 0, what are the cases that you will get? When x is not equal to 0, it means x is greater than 0. Guys, if x is greater than 0, can I remove mod without fear? Because x can be plus 5, plus 6 and mod the value will be positive. So the value of y will be 1. Guys, the value of y will be 1 if what? If x is greater than 0. If x is greater than 0, the value of y will be 1. If x is negative, the value of y will be, this part will be positive, this will be minus 1. So this will become minus 1. Guys, this will happen if x is less than 0. I think guys it is very clear to you. So what can I write about Signum function? I am erasing this part. So y is equal to Signum function is defined as this. So the value is 0 if x is equal to 0. The value is y is equal to 0 if x 0, y is equal to 1 if x is greater than 0. The value of y is minus 1 if x is less than 0. Guys, this is the definition of Signum function. Let's draw the graph. Very simple now. Let's draw the graph. It's very simple now. Yeah. Let's draw the graph of y is equal to Signum function x. So what will be the graph, guys? X-axis, y-axis. When x is equal to 0, y is equal to 0. When x is greater than 0, so this does not exist. This is 1. Let's make it straight. So this is a straight line. Let's draw it here. This is minus 1 and this part is like this. Guys, understood this? Guys, did you understand what I taught you over here? So this line is y is equal to 1, right? So this is happening when x is greater than 0. What line is this, guys? This line is y is equal to minus 1 when x is less than 0. And when x is equal to 0, guys, over here at origin, then the value of y is 0. I think this is very clear to you all. So this is the function, Signum function. So if somebody asks you what is the maximum value of Signum function? So the maximum value of Signum function is 1. What is the minimum value of Signum function? The minimum value of Signum function is minus 1. At what values are they attained? So you already know, for any value greater than x greater than 0, you get the maxima of this function. And for any values which is negative, you get the minima of this function. Say for example, guys, now the question comes, integrate 0 to 5 Signum SGN x dx. 0 to 5 SGX dx. Now many of you would have been puzzled, but now guys I have already taught you Signum function graph. 0 to 5 integration, 0 to 5 is somewhere here. So basically they are asking you what is the area of this graph. So this is a rectangle whose length is 5 and height is 1. So the answer is 5. Done, as simple as that. So integration 0 to 5 Signum x dx is 5. If they would have asked minus 5 till 5, guys, if they would have asked minus 5 till 5, so minus 5 would have been here and this area would have been also 5, but this is below x-axis, so minus 5 plus 5, this would have been 0. Very simple, guys. Below part minus, above part plus. Yeah, so if say for example this would have been minus 3, if this would have been minus 3, upper part is 5, minus 3 to 5 Signum function, below part would have given you minus 3, upper part would have given you plus 5, the answer would have been 2. Very simple. So you can take the analogy and make as many problems, solve as many problems as you can. So this was about Signum functions. I think this is very clear to you all. If it is not clear, guys, you can comment, give your comments, give your doubt, write it in the comment section and I'll get back to you on this. So next, guys, Signum functions. After Signum functions, we will be moving into greatest integer function. We will be moving into greatest, let me write it over here. So this is greatest integer function. Greatest integer function is written as like this. Y is equal to like this. This is how greatest integer function is written as, right? So this is greatest integer function. I'll first explain you what is the greatest integer function. Say for example, so what is the value of x that you will enter? What is the value of y you will get? So greatest value integer is something like this. Say for example, this is one number. So this is one number, the one number is I, integer. Yeah, and this will be the next number. So I plus 1. This is I plus 1. And if somebody says, ki, what is the greatest integer function of I? So if I put the value of I, you will get the y value as I. If I enter the value of I plus 1 over here as x, you will, so this is the number line, this is x, value of x. This is value of x, I plus 1. If you enter I plus 1, you will get how much y value of y of greatest integer function, you will get the value as I plus 1. For example, say for example, this value is 5. And say for example, this value is 6. Yeah. So what you will get, y is equal to greatest integer function of 5, the value will be 5. What will be the greatest integer function of 6? The value will be 6. So if it is integer, if the number is integer. It can be -5, it can be 6, negative integer. Yeah. So if negative number. So if it is integer, the value will remain as it is. But if a number is in between two integers, the value of x say is lying over here. So if you enter this number into this function, the value will be the previous, this side, it will move back, the previous integer. So now say for example, the value of x is 5.67. The value of x is 5.67. So if you enter, I'm erasing this. So if you enter greatest integer function 5.67, what is the value you will get? You will get 5. You have to move to the previous integer. Got it? I think this is very clear to you all. You will get what? The previous integer. I am erasing this part. Say somebody has given you y is equal to this as 1.33. So 1.33 lies in between 1 and 2, guys. It lies in between 1 and 2. So somewhere here it will be 1.33. What is the number before that? 1. So this value will be 1. Got it? Very clear? Say for example, somebody has given you guys minus 6.78. Tell me the answer. How much? Minus 5? Minus 6? Minus 7? How much? What is the answer? Majority of you will go wrong over here. Minus 6, guys, this is minus 7, this is minus 5, right? Minus 5, minus 6, minus 7. Where is minus 6.78? Minus 6.78 is here. So the value will not be minus 6, the value will be minus 7. You have to jump this side, right? Yeah. If it would have been 6.78, if it would have been plus 6.78, the answer would have been how much? The answer would have been 6, guys. The previous number, yeah. So somewhere like this it would have been. I'm jumping from 6, this is 7. So 6.78 was here. So what was the previous number? The previous number was 6. So this would have been 6. But if it is negative, it will be minus 7. Yeah. I think this is very clear to you. So this is actually the definition, understanding of greatest integer function. I hope this is very clear to you. So let us now draw the graph of greatest integer function. How y is equal to greatest integer function x looks like. Yeah. So let us see like this. This is x axis, this is y axis. Guys, understand how it looks like. Actually this point is 1. I'll just make it dotted over here. So this is how it looks like, guys. Very, very clear to you it should be, because something of this sort. So this value is 1, this value is 2, guys. This value is 2, this value is 3. Now understand, so this is also the graph. So I am just highlighting is this part is also the graph, this part is the graph. So how it is moving like this. So now what, say for example, I am drawing it over here. So this will be somewhat like this. This will be somewhat like this. So I'll just draw it in this sense. So this is the value. So this is how it will move. So let me explain you also. This is minus 1. This value is minus 2. This value is minus 1. This value is minus 2. So guys, now understand this graph. So let me plot to you. So if I say 2.33. So 2.33 will lie somewhere here. If you go up, what is the value you are getting? You are getting 2. Clear to you? 2.33. What is the value that you are getting? You are getting 2. Clear? So the graph is this one, guys. Say for example 0.33. What is the value? 0.33 lies in between 0 and 1. 0.33 lies between 0 and 1. So the value is 0. So from anything between 0 and 1, the value will be 0. Right? So this is the graph in between 0 and 1. At 1, what is the value? Value is 1. I already told you. So guys, this is the graph of y is equal to greatest integer function x. Similarly, this side also you can go and can analyze this. Now guys, very important, integration 0 till 3, this 0 till 3 greatest integer function x dx. So what is the answer, guys? 0 till 3. So basically they are asking for this area plus this area. So let me erase this part out. This was I was explaining before. So let me erase. So this area plus this area, guys, they are asking for. So what is this area? So this is 1 into 1. So this area is 1. This is 1 into 2. So this area is 2. So basically 1 plus 2 is 3. This is the answer for the greatest integer function. Now guys, you can draw an analogy. So the next rectangle that will form will be of height 3. Not the height, the length will be 3 and the breadth will be 1. Next will be 4. So basically it will go in series. But yeah, if somebody asks you the question from 0 to 5, so 1 plus 2 plus 3, 4, 5. So you can understand how you can draw this. If somebody asks from -2, so this part, take this part as negative, this part as negative, and then positive part. So that is clear to you all by now, I think. So now guys, this is all about the greatest integer functions. Yeah. So now let us see the fractional part function. Let us now see the fractional part function. This was the greatest integer function, guys. I hope this is very clear to you all. This must be very clear to you all. So now let us see, guys, the fractional part function. Guys, let me tell you, we saw greatest integer function, right? GIF. Greatest integer function, sometimes teachers or maybe books write it as greatest integer function. So this was denoted as like this. And what was the value where you were taking from this value was moving to this, right? This value we were moving, we were taking the earlier integer. There is another thing, guys, least integer function. Least integer function. Just the opposite of this. Least integer function, which is denoted like this. Y is equal to like this. So we don't close this one. So this is this part. And how do we define it? There, if this is I plus 1 and you are asked to find the value of this will go this side. Just the opposite of this. So I'm not going into details about least integer function because we have already seen in details about the greatest integer function. Least integer function, guys, it is a request that you explore this on your own. Try to draw the graph of y is equal to the least integer function the way we drew the greatest integer function and solve it. If you are okay with that, do comment and let us know whether you understood or not. If you have doubts, we can get back to you on this. Yeah, you can request for a video and I'll go on that. So now let us see the fractional part functions. Let us see the fractional part function. So how is the fractional part function defined? The fractional part function is defined as y is equal to fractional part of x. So basically this bracket is given. So what is the definition of y is equal to fraction? So understand. So 0 to 1. So fractional part of x will always lie in between 0 and 1. So will it be 0 ever? So yeah. And so 0 means, let me draw the graph first. Or maybe before drawing the graph, let me tell you one thing. So a number is given to you, say for example 5.67. A number has been given to you, say a value of x is given to you 5.67. So what does a number comprise of? A number comprises of 5 and a fraction, right? So a number comprises of an integer and a greatest integer, and the number comprises of a fractional part, guys. If I write only 5, so the fractional part over here is how much? 0. The fractional part is not here. So the fractional part, same, this is the definition of fractional part. The fractional part will lie always in between 0 and 1. It will never be 1, but it can be 0. If it is 0, it is the original number. So this is like, this has no fractional part. You got it right? So basically, if this number is x, so x can be written as a greatest integer function plus a fractional part of x. This is important problem. This is important formula actually. So basically there are many problems which we will be seeing in functions chapter, and we'll be using this and solving many of the questions. So guys, let us now look how we can draw the graph of y is equal to fractional part of x. I think this is very clear to you all. So it is very simple. It is very simple, guys. So basically this is the graph of fractional part of x. It always lies in between. So this is 0, this is 1, 2, 3. It always lies. So this part will go on, this part is 1. So it will always lie in between 0 and 1. The value of y will be, so y minimum will be 0 and y max will not touch 1. So this will be like this. Yeah, it is very clear to you all. Now you have already seen this. If you have not seen the video on wavy curve, I'll link that in the description part. You can go through those. Yeah, so this is how it will be. So this is basically the graph of the fractional part function. Yeah, this is -1, this is -2, and so on and so forth, both sides, right? Guys, there is one important question that is frequently asked again. Again, the important question is coming into the picture. This is 1, yeah, this is 1, the maximum part. The important question, guys, over here is, question over here is 0 till 3 x dx. Guys, this is the question. 0 till 3, not 0 till 3. Let's make it 0 till 100. Let's make it more complicated. 0 till 100 fractional part of x dx. So what will be the answer, guys? So basically you have been asked to find the area. So what is the area of this? This is a triangle. This is, the height is 1. So half into base into height. So base is 1 and height is 1. So half into base into height. So area of each triangle is how much? Half. How many triangles have been asked for? 100 triangles. So what will be the answer? The answer will be 50. Very simple, guys. So this is how you draw the graph and how you find the thing. So they can confuse, they can build a problem on this, but this is the basics that I am teaching you. So half the area of one triangle was how much? This is the base 1 and the height was 1. So half into base into height, half into base into height. So you are getting each triangle area as half, 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 and so on and so forth till 100, so 50. Yeah, I think this is very clear to you all. So this is fractional part of x, guys. So I hope till now you have understood the absolute value function, the Signum function, the greatest integer function, the least integer function, although I have not gone into details, but it is just the opposite or maybe related to greatest integer function. The concept is similar. And we also saw the fractional part function, the fractional part function we saw just now. So guys, basically I'll just maybe try to clarify your concepts over here by writing asking you 3-4 questions. So can the fractional part of x be equal to 1? Can the fractional part of x is equal to 1? So guys, let me write, and meanwhile you all can think. Can fractional part of x is equal to 1? Can fractional part of x be less than 0? Let me write the third one. When fractional part of x is equal to 0. So this is a question I am asking you. The fourth one, when is fractional part of x greater than 1? Question number 5, when fractional part of x is greater than 0. So guys, these are the 5 questions that I have asked you. These are the 5 questions that I have asked you. Guys, tell me, can fractional part of x be equal to 1? No, guys, already I told you. You saw the graph, right? The graph was not touching 1. So I had drawn a blank. So if it won't touch 1, right? A fractional part cannot be 1. It can be 0. 0 means there is no fractional part, right? So when can x fractional part be 0? There is one question. When x is integer. When x is integer. When x is integer, there will be no fractional part. A number x is an integer. I told you, no? X is equal to greatest integer function plus this. When will this be 0? If this is 0, you get the only greatest integer function. So basically it is an integer. Then you get x, the fractional part of x is equal to 0. I think you got it. So x is equal to integer. So is this possible, guys? So this is not possible. The answer will be no over here. Can this be negative? Guys, how will 5.67, can this be negative? This part, can this be negative? Never. No, never. When can fractional part of x be greater than 1? Guys, it is possible. Greater than 1. The graph is, I told you, the maximum value, the maxima is 1. It won't, it is never possible. Now tell me, when is fractional part of x greater than 0? When is fractional part of x greater than 0? This will be possible for all x except integer. For all x except, this is just the opposite of this. It is 0, it is not 0. For all x except what? Integers. Say 5.67, 5.33, 2.11. So these are all what? These are not integers. Yeah, these are some numbers. So basically these are some. So for all values of x except integers, this fractional part of x will give you a value greater than 0. So guys, I am stopping this video over here. So this was a video that was built on the special functions that we have, and this is one of the most important videos that you must watch and get very acquainted with this. So guys, if you have any doubts, do post it in the comment section. I'll get on to that. And guys, if you like this video, do subscribe to our channel, do share it in your circle, do share it with your friends. Thank you so much for your time. Thanks for watching.